Hey, all you cool cats and kittens. Oh, wait, yeah, let's do some chemistry. So one skill that's going to be really important for you going forward in your chemistry career is learning how to count atoms. So given a formula, which we've just come up with for simple ionic compounds, we want to know how many atoms are in those compounds. So what I've done here is I've just given you a simple example of a reaction that actually takes place in nature. So photosynthesis. So most of you would probably say, hey, I know what photosynthesis is. It's where green plants make their own energy, which is kind of true. They don't really make energy, they convert energy into a usable form, but how they do that is actually this way. So they take in carbon dioxide from the air, they also take in water, and they combine those two together, and the energy from the sun, or in this case it's written as light, will jumble these all up together and you get out new stuff, and that new stuff is glucose. And if you know anything about this word, lots of times if they end in OSE, they're different types of sugar. So glucose is actually just a sugar plus oxygen. So we know about green plants making oxygen. That's why we keep them around, because they give us oxygen to breathe. And they make their own energy is what you guys say, but they really are just converting energy into sugars, which can be used later as a form of energy. So when we change all of these things into formulas, carbon dioxide is CO2, water is H2O, glucose, I wouldn't expect you to know this, is C6H12O6, and oxygen is O2. Now when I was saying that, I left out a couple things, and that's this 6 here, this 6 here, and this 6 here. In grade 10, we'll talk about why those are there, and just as a little heads up, it's to make sure that this is balanced, if you've ever heard that word before in chemistry. But just like in your math classes, anytime you have a number out front like this, 6, 6, 6, those are called coefficients. So you think about if you're looking at a polynomial, if you have a 6x squared, this 6 is a coefficient. And same thing in science, in chemistry, if you have a number out front of a formula, that's a coefficient. There's no coefficient written here, so what do you guys think that might be? Little hint, we're not lazy, we're efficient. So oftentimes, if something's not written, it's actually a 1. So there's a little coefficient of 1 here. So what we want to do is we want to count up how many atoms are in a couple of these. So let's take a look at the first one. I'm just going to write it here at the top, 6CO2. Now when I get you to count these up, it's often easy to make a table like this. So take a look at the different types of atoms. We've got C for carbon, we've got O for oxygen, and that's it. That's all we're dealing with. All right. Number of atoms. Let's pretend for a second that this 6 is not here. So how many atoms of carbon do we have? Again, it's not really written here, but there's a little 1. So we have 1 atom of carbon. How many oxygen do we have? We have this 2 right beside it, so we have 2 oxygen. So 1 plus 2 gives us a total of 3. So if we have CO2, carbon dioxide, we have 3 atoms. However, we've got this 6 coefficient out here. So what does this mean? This is shorthand. Instead of writing CO2 6 times, we just put a 6 out front. So if each molecule of CO2 has 3 atoms in it, if you have 6 molecules, how many atoms do you have in total? Well, all you do is you multiply by 6. So 3 times 6 is 18 total atoms. Let's look at one of the other ones. Let's look at I don't know, let's do 6H2O. So what types of atoms do we have? We have hydrogen and oxygen. How many atoms do we have? Again, I like to ignore this coefficient of 6 at the start and just look here. So how many atoms of hydrogen? We have 2. How many atoms of oxygen? There's no coefficient here, so what do we know that actually is? It's a 1, so we have 1 atom of oxygen. 1 plus 2 is 3, and this coefficient, let's I don't know, let's change it up actually. So it's not the exact same as last time. Let's give this a coefficient of 10. So let's say we have 10 H2O. So what do we do down here? Well, if each H2O molecule has 3 atoms, if we have 10 of them, all we do is multiply by 10 for a total of 30. Pretty simple. Let's do one more example. This one looks a little bit trickier. Grade 10, you'll learn how to name this. This is calcium nitrate, and we'll talk more about that in grade 10. But to count up the number of atoms, let's do the same thing. We make a table like we have here. Write down our types of atoms. We've got Ca for calcium, we've got N for nitrogen, and we've got O for oxygen. So what's different about this one from the last question? Well, we've got a set of brackets in here. So we got to deal with that, okay? So let's look at calcium. How many atoms of calcium do we have? Well, we would look at the little subscript right beside it. It's not written, so it's a 1. So let's put in 1 here. All right. What do you think this 2 means outside the brackets? So what this 2 means is it applies to everything in the brackets. So rather than writing CaNO3 NO3, we can say there's 2 of whatever this NO3 is by putting a 2 outside the brackets. So this 2 actually applies to everything inside here. So when we're counting up nitrogen, the little coefficient, or sorry, the subscript here is 1. But this 2, it means there is 2 of everything in here. So we're going to multiply by 2. So that tells me I have 2 nitrogen. What about for oxygen? Our subscript here is 3. But this 2 outside the brackets goes with everything inside the brackets. So 2 times 3, or I guess I have it written here, 3 times 2 equals 6. So let's add those up. 1 plus 2 is 3, plus 6 gives me 9. Let's not forget one last thing. We've got this coefficient of 7 out front. So what do we have to do? We need to multiply by 7, and that will give us 63 total atoms. I'm not going to give you anything harder than something that looks like this. Just know that a coefficient or a subscript outside the brackets applies to every single type of atom that's inside the brackets. So why don't you guys go ahead and try out the Counting Atoms worksheet, practice these, and good luck.